So one more look at the prior business object diagram where we had stars and planets and asteroids and planet satellites and a system of such, and also some physics engine that can do some computation of orbits and things like that, right? So over here we could maybe design a system like Planet that would have a number of satellites, right? So we could also introduce aggregation in this design pretty much at any point we want. Perhaps we could say that Planet is the holder of the collection of the satellites, right? So it can have its own satellites, obviously natural satellites, right? And so if we wanted to aggregate this into the system, we can say, you know, anytime you construct the planets and it has the satellites must be created at the same time. So you can do this type of aggregation right here, right? So we can indicate this. Of course, we want to erase the internal part and display that we have this type of relationship. So if that's the case, then again, this would be our example of this aggregation. Let me just move this piece down here, okay, and restore my connections to everything, right? So so this would be, you know, perhaps a place where I would want to use association between the satellite and the planet, and indicate that at runtime, when the system executes, I want to make sure that the satellites are constructed at the same time, like really, really close to the time when the planet is constructed, right? So the same, sometimes we can go for more, and we can say when the star is constructed, we also want to aggregate it with its own planets, right? So this essentially imposes on the programmer a bit of more constraint in terms of when to construct these objects. So you don't want to, even if your configuration tells you that this planet, right, like Earth, has the moon, okay, you don't want to create this Earth planet and let it hang there and do other things and only then create the moon. It basically, you need to prepare for the creation of the planet alongside with its moons, you know, at close times, you know, in that proximity, and make sure that you gather all the attributes you need to pass to the constructors of all of these objects that you want to create, right? So essentially, this strengthens the design, telling us that the life cycles of objects are very, very much related, and this is usually good information because you want to understand, you know, you want to have this additional information about your classes, that they're so closely related, okay? So basically, aggregation and composition works very well with any sort of like physical devices, right? So you can have like a disk drive with a controller in it, okay? So obviously, controller without the actual disk drive makes no sense, and vice versa. So that would be objects that you want to closely have them aggregated and use this specification. And also the shapes of aggregation on the diagram indicate who is the aggregate and who is the part, which is also good knowledge, right? So I'm just, I would be asking you actually to maybe think about possible examples when you work on this on this questionnaire of, you know, on this form for a midterm exercise, right? When you want to fill out these examples, what I'd be asking you to do is to maybe use our semester project and use classes or objects from that system to use as examples where you need to provide examples of all of these relationships. Perhaps inheritance is the easiest, because inheritance essentially specifies types and subtypes, but other things, just think about it, right? So maybe in our situation, a bank of elevators, and the actual elevators probably are pretty close to aggregation by value if this was written in Java, simply because it makes no sense to construct a bank of elevators without the actual elevators. Perhaps the construction of these should be done pretty close in time, in that proximity, and it just could be one of the good examples where aggregation may be helpful in terms of understanding what the system really is. Okay, so think about it. We can go back and discuss those ideas again on Thursday, but today we'll just finish this segment, I guess, by going very quickly over the formal set of slides we have for use cases, because right here for the midterm, I'm asking you to submit the diagram of business objects, and you're welcome to use all of these relationship types. Association, which basically is one object referencing another. By the way, example of association in C++, right? So that would be another thing for us to mention here. Remember that on our diagram, we also had this rider, which also is associated with a scooter, which basically referencing the scooter. So right here we can just say class rider, right? A rider, and the rider would like to have access to the vehicle so that they can control it and do things, right? So we can say that maybe it has a private reference to the scooter, and one of the obvious choices here would be to use a pointer, right? So I normally name pointers P with the P prefix, right? Like P scooter. So this is a reference to the scooter. So that way, the rider constructor, right? So we can have this public constructor over here. This is a true composition. So perhaps we want to simply want to take pointer to scooter as a parameter to this constructor, okay? And normally these things are initialized by the initializer list in C++. So that's why I'm using the syntax to say, okay, here's the scooter initialized, and so that would be a version, the C++ version of doing something like this in Java, right? In Java we say this dot scooter equals scooter, right? So something like this. So this would be a Java version of it. In C++, of course, this is a pointer and not object reference, so therefore we need to use this pointer to object dereference operator to express it thoroughly. But this would be considered to be inefficient in C++. Instead, you use member initializer list and use this constructor type syntax to initialize your objects. So this time I can say rider, right? Rider, and I want to construct the rider in my main program, and or main function rather, right? And so the constructor will simply take the address of the scooter to use as as the constructor parameter, right? So we need to take the address of the existing object, which is this object, and construct it this way, right? So if you really want to have this precision in terms of like when you construct your objects, you could have said over here new scooter, right? Which is a very also typical type of work that is done in Java as well, right? So in Java, it's very practical to say new exactly when you call some kind of method, just using this method parameter, right? But in this case, in C++, you don't want to use new without some attention to what's going on, because perhaps in this case you need to be able to destroy the scooter at some point, right? So you need to be, so if this object now encapsulates pointer to dynamically created object scooter, then you probably want to have the destructor. Okay, and the destructor syntax, of course, is the tilde name of the object in C++, right? So this is a destructor. So in this destructor, what you want to say delete. Delete the scooter, clear the memory, make sure that anytime the rider is destroyed, the scooter is also destroyed. So essentially, the responsibility of the rider may well be to destroy the scooter as soon as the rider goes out of scope, because it's only the rider that has access to the address of this object in space, and there is no automatic garbage collector in C++ to do something like that. However, if you include memory right here, right? So if you say include memory, then you can basically automate this process of the deletion by saying this is that you're using unique pointer. So actually, let me just duplicate this unique pointer. Okay, so unique pointer to scooter, something like this. Unique pointer to scooter, and this is going to be our scooter thing. Okay, and that way, and this needs to be resolved as part of standard library, and so this way your scooter, and again this will be commented out as it was before. Now we can say scooter and simply constructed from the pointer that was passed to it, and so this way you no longer need this destructor, because the object will be destroyed automatically by this helper object. So this unique pointer that comes from the memory header is your little version of garbage collection in C++. Essentially, it's a helper object which says, well, you know what, if you just give me the pointer of an object when you construct me, I will remember that anytime this rider object is destroyed, therefore the scooter thing goes away, I will call the delete on that pointer, and will be able to avoid memory leak, losing an object which would otherwise need to be destroyed. So just a few notes so that you know that in C++ is also, there are ways to deal with that. But I just don't see why I should be doing all of this if I can construct it like this explicitly and just pass the address to my rider constructor if I wanted to. So anyway, these are some considerations and some variations on what you can do in C++.